Thanks, Valentina. Hi, guys. Welcome to the Kubeflow Virtual Symposium. My talk is gonna be about uh, doing feature engineering and or pre-processing of data at scale with the Spark operator, which recently became a part of Kubeflow. A brief introduction about myself. I'm the founder and the principal consultant at RAICS.AI, and it's a MLOps-based consultancy firm out of Sydney in Australia. So yeah, if you're seeing me in a jumper, that's the reason is because it's pretty cold over here. We are in the southern hemisphere, and uh, coming back to the topic, feature engineering, why this may be required at scale. The answer to that is the need for it is mm, uh, in real in reality, big organizations have massive volumes of data, and they are affected by the four V's of data, primarily the data volumes, data velocity, but the data variety, and also data veracity, which is pretty much about the quality of the data. And in order to basically execute meaningful use cases to improve customer experience or estimate customer lifestyle value or even predict customer churn, they have to process years worth of historical data and derive meaningful features out of it. Now, ML models, as we all know, are only good as the features they get. It's the principle of garbage in, garbage out applies very well to the machine learning or data science domain as well. So, and again, creating meaningful features requires joining multiple large data sets, which could be very difficult to do, or in many cases, not even feasible to do on uh, single machines or servers. So that's why there's a need for distributed computing, and Spark, which Spark has been doing it for years. It's quite popular for that. Also, Spark has its own machine learning library, uh, the called Spark ML, which actually enables you to do distributing machine learning models using commonly known algorithms. And with the introduction of Spark Operator, which initially was initiated by Google, it's become, and now it's recently become a part of Kubeflow. It has actually covered the gap of doing the feature engineering on scale, which Kubeflow didn't, which Kubeflow had missing for quite a while. But and this is something which we have leveraged in terms of our engagements, which we have done for many customers. Now, one of the things before I start with why Spark on Kubernetes is important, and a lot of it, the points you'll see are actually about Kubeflow as well. Uh, uh, that why Kubeflow plus Spark actually is Spark is or the Spark on Kubernetes is actually a makes life easier. So one of the reasons is uh, my one of the some of the reasons over here are the packaging and portability. You build images with the library and dependencies pre-installed without having to worry about writing bootstrap scripts the way it was typically done on Hadoop clusters running Spark. And the other one advantage, which one of my favorite, is that with Spark Operator or with Spark on Kubernetes, you could actually have a declarative GitOps friendly job submission. Your job submission is actually done through a YAML file, which can be version controlled as well. So if you're adding custom parameters, uh, or you're actually adding config files, which typically used to do with uh, the conf parameter or with minus files parameters with Spark Summit, they are all actually done slightly differently, but through a YAML. And so those commands are actually not lost. Spark also needs uh, Spark also needs scaling up of executors, with dynamic allocation. And one of the problems which with Spark, is, especially with the Hadoop timing, was to actually isolate multiple teams, because they were, although there was a concept of resource queues in Cloudera based platform or Hortonworks platform with Yarn, but it was not giving a complete transparency of resources between various teams or users, and so people were actually overstepping on each other's shoes. With Kubeflow or with Spark Operator, you have multi-tenancy. Everyone is actually isolated on their in their own namespace, so and you could put caps over there, so that way you have a guaranteed resource allocation for each and every team, and two teams are generally are not fighting with each other over resources. And for me, the Spark and Kubernetes combination is like Deadpool and Wolverine, that they both have their own advantages, and they really complement each other very well. Spark can do distributed processing at scale, and Kubernetes, for example, can provide uh, the underlying platform along with its auto scaling capabilities if enabled. There's a security based security and configuration management. uh, Kubernetes RBACs allow you to enable them. If you are running your cluster in a cloud environment, for example AWS, you could very well integrate your IAM roles. You can define IAM roles for each team to run your Spark jobs, and thus controlling access to other cloud resources, example the S3 buckets. And in and the if you're using something like Redshift or a, Snowflake, you could also control what data a particular team can access to. Again, cost and efficiency are cost and efficiency is another a very good advantage of running Spark on Kubernetes. The idea is actually to get the best of the old world of running of the Hadoop clusters, where you would actually run your jobs on a dedicated cluster and max out and make the maximum resource use of resources. While the modern cloud-based Spark platforms like EMR uh, and others, they actually enable you to create uh, different clusters for different teams or different workloads. But again, the cost that they are not very cost efficient. But here, with running Spark on Kubernetes, two teams could still share the same node, but they could be practically isolated from each other, as in they are not actually fighting for resources because they've got their own dedicated resource quota. And the other flexibility Spark on Kubernetes offers, that other Spark and non-Spark workloads can uh, coexist. It integrates very well with other tools and technologies. For example, tools like Airflow, Kubeflow Pipelines, there is seamless integration with them. And again, my personal favorite on this one is you could actually run different versions of Spark within the same team or within the same profile uh, at the same time, and without actually a like the old Hadoop world, where you could only run one Spark version, or at maximum two, and every time it would be a big upgrade exercise. Now, coming to Kubeflow pipelines and Spark Operator. Although Spark Operator became recently became the part of Kubeflow, but both Kubeflow V1 and V2 uh, 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 supported Spark Operator. People have been actually submitting their jobs in V1. The resource op API was the most widely used to for doing it. It would actually generate the YAML file for you behind the scenes. But in Kubeflow SDK, the approach is to use the intermediate representation, or the IR file, by generating a reusable component. So typically with Spark Operator, you define your Spark job uh, as a YAML file, and then on a Kubernetes cluster, you do a kubectl apply -f to submit the job, and Spark operator takes care of submission. And in the next slide, we're going to take a look at the sample manifest file. And on the coming slides, I'll be mainly referring to the uh, V2 API for both SDK and Kubeflow pipelines. So typically, this is what your YAML file which the Spark operator prefers. The first two lines are pretty important, as they define uh, that The API version, the first part of API version defaults that it's actually the Spark operator, which would be used to process it. So, and the second one is what kind of resource would it be? In Spark applications on Kubernetes are run as a custom resource definition of a Spark application known as Spark application, and rest pretty much is standard Kubernetes terms like the name of your job, and the spec contains what type, what image to use, what is the main class, what is the application file, and where it is located, um, any command line arguments, the Spark version to use, and the driver and executor parameters, including the codes and memory. Now, when you actually submit it through Kubeflow pipelines, so in V2, uh, we define the pipeline. Actually, in Kubeflow pipelines, we define the pipeline, whether it's V1 or V2, we define it as a Python file, and then we compile the Python file as an IR generated YAML, which is the hermetic representation of the pipeline. The Python decorator I used to define the components of the pipeline and the pipeline itself. If your pipeline needs to run multiple tasks, each of them would be individual component, but there would be only one section for the pipeline itself. And as a best practice, it's highly recommended to specify a base image for, sorry, there's a typo over here, for each of your components, as the default ones may be outdated when you're running it in a production environment. This might be quite important for you that you're not using outdated components, as they might have security vulnerabilities associated with them. So here's a sample pipeline, which what it does is actually takes the name of a person as an input, and in as an output, it actually generates hello plus the name of the person. So I've divided into two parts. So the left one is the component, which is I've defined the component as hello. You can see the component decorator highlighted in green, and below is the definition in the form of a Python function. And all what it's doing is taking the name, which is string, and returning a string, which is hello plus name plus exclamation marks. And on the right side is typically the uh, the pipeline component using the dsl.pipeline decorator, and it's actually defining a hello pipeline, which actually calls the hello component over there. So everything which you define as a component needs to be specified in a pipeline as well, in a pipeline definitions, otherwise it would be skipped. And once we actually submit Spark, once we submit a pipeline, on the back end, what happens is, because Kubeflow pipelines is Argo CD based, so it's create a Argo CD workflow, and you will typically see a in V2 that it actually creates your pipeline name hyphen dag hyphen driver uh, pod pod, which is basically the pod controlling the entire uh, dag or pipeline. Then there is a container. Uh, there's one single. It is one single for the entire pipeline, and but for each of your components, you will see two pods. One is the container driver, and the another one is the container implementation. The container driver simply prepares the execution, and in the container IMPL or container implementation pod is the one which actually runs the actual code. And this is where the kubectl apply a, a, a magic happens if you're running a Spark workload. And on apart from this, if you are running a Spark job, your pipeline submission also creates a Spark application CRD, and also it creates a driver and executor pods uh, in the desired namespace. So I'll quickly jump into a demo for a Spark pipeline, and it's actually based on the Spark Py job. Give me a minute, and I'll just bring it my other screen as well, so that I can actually show you the pods as well. And let me clear all workflows, so it's pretty okay. And I'll quickly compile. So I'll quickly go with my pipeline code. So Over here I've templated my Spark YAML and this is basically a the YAML of which I showed previously. This one is uh, this one is actually directly populated from the Spark operator repository under the examples folder. It's called there it is Spark Py it's called spark-py.yaml. And coming down, I've defined, as I was talking, I've defined my a component, which is basically submit Spark application. Don't worry about the this highlighted part, because what I've actually done is uh, I've actually append this particular part is actually to append the workflow, a unique um, workflow UID to my Spark application name. Because what happens is if you go with a default the default name which is specified over there, which is Spark Pi, if you were to rerun the pipeline, because the CRD Spark-Pi would already exist. So the new submission would not take place, because I keep on experimenting with this. So that's what the part I've done over here. But all it's actually doing is taking the YAML string uh, defined above, and uh, it's actually writing it as a in /tmp/spark.yaml, and then doing a kubectl apply on that, and then returning the Spark application name. And the reason I'm returning the Spark application name over here is basically in my next part, I monitor my Spark job. And here I've written the logic for that. And the reason for that is in many cases, in many enterprises, your team, your data science team or the data engineering team who's actually using Spark operator, they uh, and submitting jobs through Kubeflow UI, they might not have access to the underlying Kubernetes APIs. So they might not be able to directly see the logs using kubectl because they don't have access to it. But uh, with this component, what I'm doing is basically pulling the Spark application, and when the status is actually completed or failed, it would actually get the driver pod logs. Uh, Once the presentation is shared with you guys, there is actually a link to my current code repository where all this code is sitting, in case if you guys are interested. And I'm also working with the Kubeflow Pipelines team to get it included as an example uh, in the pipeline example repository as well. So the last component is basically the pipeline operator, and there I'm defining the submit task and the fetch driver logs task. I've For now I've disabled the caching again for the same reasons that I when I was experimenting it, I wanted to run every time. And the last component is basically just about compiling the pipeline, which is pretty much standard. So going back, if I compile it, yep. So it will generate the Spark pipeline, pipeline.yaml file, and this is the file which I'll be using for my local Kubeflow pipelines. So let's create a pipeline. Let's call it demo. So it's in KFP, Spark KFP. Yeah. Now the pipeline. Sorry, give me a minute. Oh, this is not the right one. Give me a minute. Let me just delete it and recreate it. Sorry, my bad. Upload pipeline. Okay, wrong code. Yep, spark.py.yaml. Yep, as you can see, now it's actually populating the pipeline correctly. The first job is just I Spark submit for my a Pi job, and the second task is my fetch driver logs. And another thing is one of the I'm actually exposing the driver logs and an artifact. That's why you see as a block, but it's actually not a task. If you look at the folder sign, it's basically an artifact. Now I'll create a run for it. And one of the key things to notice that the arguments are actually passed as part of the YAML file itself. So going back to over here, the this is one of the limitations which we'll be talking about. It the arguments are actually passed as part of your YAML file. And uh, one of the limitations currently which exist is that these para arguments are do not appear on the Kubeflow pipelines UI. So if you were you have to cater for extra logic into your code if some part of your argument is, for example, a particular database partition that you want to read on a particular day. In case you are setting a recurring event, you have to cater the logic yourself. But we'll be talking about these limitations. But um, uh, both the Spark operator teams and Kubeflow pipeline teams are actually working on to minimizing those. So let me click on this run, and it's actually running over here. And if you look at, sorry, kubectl in my setup, my Spark jobs, I've actually installed everything locally. My Spark jobs are going to run in my default namespace, but everything, all the pipelines run actually in the Kubeflow uh, namespace. So but if you look at it, the Spark pipeline has actually been created. And if you do a get pods, you'll see, as I was talking about, that for each of my so this is a DAG driver, which is basically the container for your uh, pipeline. And for each of my tasks, I've got a driver and a IMPL task. Currently, if you see that uh, both the drivers and the IMPL task for the Spark Py job has completed, and I think it's now just running the second task, which we can verify from the UI as well. And by the time we came in, both of them ran, both are green. And if I were to access my Spark driver logs, I could actually go over here. One thing to note over here is if you go to the log section in your Spark application, this one actually just does the Spark submit. So you'll only see the part where it's actually doing a kubectl apply. You don't actually it's all about this particular task which shows up. It's actually all about um, the firing of the Spark job. If the Spark job fails, uh, this part would still be green. So usually people actually do a monitor Spark task, but I'm doing that as part of my fetch driver logs, that if my job fails, it would be the logic is taken care of it. uh, uh, so you can actually define your own approach whether you want to actually have a separate monitor task which would actually turn red if your job fails, or you could incorporate the logic over here. And basically in a typical currently here I'm using minio for generating my Spark driver logs. But in a typical deployment, you would probably redirect it to cloud-based storage like S3 or something. And over here uh, from the Kubeflow UI, you could actually download it, and if you want, you can actually view it as well. And if you look at it, it's pretty much all the logs. And the last one of the last line is basically it's computing the value of pi, which this code does. And that is what is over here. So this was pretty much the demo which I wanted to talk about in terms of integrating Kubeflow pipelines and uh, uh, Spark operator. And give me a minute. And coming back to the limitations, one of them we have already talked about is basically about the Spark job. That's the second one on the list. The Spark job parameters are not exposed to Kubeflow pipelines, so it's not possible to change them through UI. And uh, uh, and this is pretty important if you're doing and the other one is if you're running it in a cloud environment where something like Istio is used, uh, then there would be a sidecar container, Istio sidecar container running. And by default, which we when we were doing this for the first time, we saw that all our jobs ran successfully, but it didn't go to the next task because the Spark application was marked, the Spark driver pod was marked as not ready because the sidecar container was still running, and so it never moved to the second task. So we have currently disabled the sidecars, but again, this is I still need to raise it with the Kubeflow pipelines team, but that is also work in progress. And speaking of use cases, the two use cases which we actually, one of them we have implemented to some degree, is basically doing OCR on Spark. The client over here is a financial institute. They don't want to be named because they don't want to expose their tech stack. But they're not a bank, so they don't do everyday banking, but they do offer personal loans, home loans, and other loans, uh, and also credit cards. They've been an old school for quite a while, but they decided to. Yeah, their main power was actually their products and their competitive rates when it comes to the home loans, the interest rates on loans and stuff. But now they've started a data-driven analysis, and they've got a lot of use cases. So one is customer lifecycle value, and also the other one they're actually trying to work out is the responsible lending, where they want to make sure that they don't lend more money, a lot of they can genuinely lend that amount which a person can actually afford. Previously, they were operating on a product level, but now they've decided to go on a customer level to actually counter for this one. And one of the interesting things about them is they have been in business for more than 40, 45 years. And being old school, for a lot of time, they've been using PDFs uh, for the paperwork involved. And the history, they, as part of their digital transformation, what they did in the early 2000 was actually scan them, all of the PDFs, all of the handwritten forms, and upload it to a shared drive, which kept on growing, which is now currently a sitting in a cloud on S3. Even the loan applications today are actually done through, although they are done through online, but it's actually generate a PDF uh, uh, in the on the background for the loan officer to review. And the loan documents include other PDFs like salary slips, your tax return statements, and stuff. And they kind of get 60 to 65 GB of data per month. When we were actually looking at uh, their entire historical data, uh, which is from kind of starts with 1990s, it's a roughly around 1.2 petabytes of data volume. And although, because doing it in one go won't be possible, and they started the data the shared drive which I was talking about, which is now currently sitting on S3. They only started organizing folders into it, or organizing PDFs into this, in terms of uh, dates starting in 2015, and it's just done on the financial year. But the history before that is all sitting at the root of that bucket. And uh, so what we are doing for them is currently one of the jobs which is running since Monday is actually just parsing the metadata. It's a Spark job, and it uses Apache to basically pass the metadata of those PDF files, and it's kind of copying them into another directory, where we are actually using the creation date of the PDF to basically identify or categorize into a particular year. And uh, Tazrac again is used on those PDFs, which are basically scanned images. And in many cases, people have just provided images uh, from their cell phone, of their pay slips, of their financial statements and all. Those would be processed with Tazrak. That's one of the we have been successfully able to run it over with roughly around 800 to 900 GP for each year since starting 2005, 2015 uh, till uh, last year, till the last financial year. But there's more work to be done, and also uh, with the content generated by Tika and Tazrak, they're also looking at how to organize that data in to form meaningful tables for them. And there are quite a few challenges with it. One of the biggest challenge, the tech challenge, which for us was the schema evolution. That uh, for example, payslips for different employers have a different schema altogether. So schema evolution is a big change, and again with their own forms, they have changed over a period of time. So that's the structure, the number of fields in the forms have changed. And because a lot of it is historical data as well, so it's very difficult to come up with particulars uh, uh, with a particular schema for that one. But currently eh, because we are using Tika, which generates a JSON stream. So we are actually currently going with Apache with Apache Avro in terms of converting that to uh, converting it to Avro format, which is again kind of JSON based and supports schema evaluation, so that we can finally come up with we can cater for missing or extra fields dynamically on the fly. But the end goal is to basically transform them into meaningful features and put them into a more queryable form.
Thank you so much, because I know we are past time. I don't know if you want to close out in a few seconds.
Yep, sure. The rest one is the other use cases, Feast and Spark. I won't go into detail in this much, but again, uh, uh, you'll actually have the slides with you shortly. And some of the code which I actually talked about is actually sitting on GitHub Repo. The link I've included the side deck, which would be shared with you, and uh, and the environment details is also mentioned over here.
Thank you so much, and thank you for the live demo. We know how challenging it could be, and it was amazing. So thank you so much. So there are many questions actually, and potential discussions to be, on the chat. So I don't know if you could stay around, or otherwise share your Slack ID, and people can reach out to you. That will be amazing.
Oh yeah, I'm on CNSF Slack channel, so you can reach out to me over there. And I'll look at the questions after this.
Perfect. Thank you so much. Thanks, everyone. So let's give you 2 minutes so you can take a short break, and then I will see you for the next session. Thank you.
Thank you, guys. Thanks a lot.
Thank you so much for the session. It was amazing. Thank you.
Thank you.